Is there anything more mysterious, intriguing or unknown than a black hole? Answers in the comments. But, for now, it's clear that when it comes to space and the cosmos, black holes are a never-ending well of wonder. A bottomless pit of potential. But they're also one of the trickiest things to wrestle with in all of science. Over the years there have been countless theories put forward as to their true nature. And, in recent times, we have begun to get a better grip on them. But, still, there are some ideas about black holes that, if they were ever proven to be right, would change our understanding of everything, forever. Welcome back to our channel, and today we're taking a closer look at a bizarre theory that black holes could double up as portals. Do you need the big questions answered? Are you constantly curious? Then why not subscribe to Everything But What for more clips like this one? And ring the bell for more thought-provoking content. It's often said that you can find yourself down the rabbit hole whenever you spend time researching big hypotheticals and alternate theories. Sometimes it's pretty fun down there, and sometimes it's a little bit frightening. But, really, it's black holes that represent the ultimate rabbit hole in actual, physical existence. These are truly massive openings in space itself, and it's a one-way ticket for anything that enters them. If you were to fall down the rabbit hole of a black hole, then you ain't coming back. These enigmatic cosmic objects are often characterized as ruthless monsters that devour everything in their vicinity. Nevertheless, they've long captured the imagination of scientists and space enthusiasts alike. In general, black holes are formed from the remnants of massive stars breaking under their own gravity. When massive enough stellar cores exhaust their nuclear fuel, they undergo a collapse so dramatic that the gravitational force involved becomes so intense that it warps space-time. Eventually, it's a process that creates a specific region from which nothing can escape. In the structure of the resulting black hole, this point of no return is ultimately known as the event horizon. Not all black holes are equal, though. There are various types, including stellar black holes, which again result from the collapse of massive stars, but also supermassive black holes. These are usually found at the centers of most galaxies, including at the heart of our own Milky Way. The formation of supermassive black holes is a little less set in stone, with theories ranging from them being produced when a tightly knit star cluster collapses, or when other, smaller black holes merge together. Overall, the estimated number of black holes in the observable universe is vast, ranging from tens of millions to possibly multiple billions or more, depending on the model and method used to calculate. Given that there are so many unknowns swirling around these immense celestial structures, it's perhaps unsurprising that black holes have become a magnet for outlandish ideas. But actually, the one at the top of today's video, the idea that black holes could also be portals, isn't really so radical or off the wall. For decades, theoretical physicists have suggested that they might also be gateways to other dimensions or even parallel universes. So how would such cosmic connections unfold? In one sense, the key word is wormhole. Much more than a glittering highway in your favorite science fiction movie, wormholes are genuinely hypothetical tunnels in space-time that could connect two separate points in the universe. Proposed within the framework of Albert Einstein's general relativity, they're often visualized as bridges. More directly, the Einstein-Rosen bridge is a specific type of wormhole that also works as a shortcut through the fabric of space. In general, it's said that that fabric, otherwise known as space-time, could be manipulated so that 2 points even light years away could be brought together. It's often demonstrated by marking 2 points on a piece of paper, folding that paper in half so that the points match, and piercing a pencil through both. In a pretty primitive sense, that's a wormhole. And that's what some have said could be happening inside black holes. We of course know that any matter that falls into a black hole is apparently lost forever. Given that black holes themselves will eventually disappear, as well, this is a problem, known as the information paradox, that has long puzzled researchers, because quantum mechanics says that nothing can be totally lost. However, if black holes were portals, then the information paradox is solved, because any and all matter and information that falls into one is then set to re-emerge out of it, somewhere else. In some models, this exit at the other side is known as a white hole. But more on that shortly. First, there's the holographic principle to consider, as well. This again rests on the quantum reality that information of any kind should never be lost. Only, here, the explanation for what apparently happens in black holes is slightly different. The holographic principle proposes that the information inside is somehow encoded on the event horizon in a two-dimensional form. Some theorists then suggest that, at this stage, the information that was once physical matter could be transferred to, or at least imprinted onto, another plane. So, here again, a black hole would work something like a portal. Perhaps not in the more traditional wormhole sense, but it would still represent a checkpoint between here and there. Still, the concept of white holes is key. While black holes devour matter, white holes theoretically expel it. They are imagined regions of space-time into which nothing can enter but out of which matter and energy can freely and rapidly exit. Whether it's fueled by the holographic principle or propped up by a relatively simple wormhole, the discovery of a white hole would be the smoking gun moment for all theories toward black holes being portals. The problem is that, so far, there are no white holes that we know about. Nevertheless, many theorists remain confident. The reason why has to do with how we answer the related question, where do black holes lead? The possibilities are not only as vast as the universe itself, but also as wide and unending as the multiverse. So much so that it could be that no black hole leads to another point in this universe, and that's why we have no white holes to speak of. Instead, all black holes funnel their matter into a different universe, and the black holes themselves are therefore the key infrastructure in how the multiverse works. It could be that they foster connections between us and parallel universes with entirely different physical laws, or alternate planes made up of multiple extra dimensions beyond our own. Such a radical rethinking of how the universe works more than stretches the boundaries of our current scientific knowledge. It essentially destroys everything we thought we knew. For some, it's a possibility that ties all the way back to the beginning of matter itself, the Big Bang. For decades, the Big Bang theory has been the leading model to explain how the universe came to be, but discussion of it is always overshadowed by one, seemingly crucial problem. If everything came from the rapid expansion of one singularity, as the Big Bang says, then where did that one singularity come from in its first form? How did something come from nothing? Well, what if the Big Bang was actually a white hole? In fact, what if it still is a white hole in action? While highly speculative, increasing numbers have begun to debate the possibility that, actually, the entire universe is merely the product of the exit point of a black hole portal, one that was opened up around 13.8 billion years ago, to our minds. This exit point, a massive white hole, can account for literally everything we know about. For our physical reality and for its continued expansion from that point onwards. Could it even be that it's the irresistible force of an expelling white hole that's powering universal expansion, in general? Questions like these aren't yet mainstream, but the allure of white holes has gotten plenty of people wondering. So, what's your verdict? What do you think happens inside a black hole? Is there any merit to the suggestions that these brilliant behemoths might ultimately be cosmic gateways, at their heart? And, if it were possible to travel through one to reach another side, then is it so unlikely that that's all this universe is, as well? Another side from the point of view of somewhere else across a multiverse that's connected by these dazzling bridges? Because that's the bizarre theory that black holes could double up as portals. Black holes are among the most mysterious objects in the universe, ready and willing to devour anything that gets too close to them. Luckily, the closest black hole to us is more than 1,000 light-years away. But what would happen if one showed up actually on this planet? Welcome back to our channel, and today we're answering the extraordinary question, what if a black hole appeared on Earth? Do you need the big questions answered? Are you constantly curious? Then why not subscribe to Everything But What for more clips like this one? And ring the bell for more thought-provoking content. Because black holes generally form when a star dies and collapses, they themselves are extremely massive. For an ordinary black hole, you first need a star with a mass at least 8 times greater than that of our Sun, which is why the Sun will never become a black hole itself. Supermassive black holes naturally demand even more mass, while ultramassive black holes have a mass more than 10 billion times that of the Sun. The largest discovered so far was found in 2019, at an incredible size of 40 billion solar masses. If a black hole this size, or anything remotely close to this size, came close to Earth, the entire population of the planet would quickly die, and not in a pleasant way. When you fall into a black hole, the force of gravity acting on your feet is so much stronger than the force of gravity acting on your head that you get stretched out. Infinitely stretched out. Until your entire body is reduced to one long, single string of atoms, which ultimately gets crushed down into the singularity like literally everything else. This process is called spaghettification, and, were a black hole to appear here, it would happen to all of us all at once. All of us together, plus everything we've ever known, being ruthlessly, inescapably pulled apart at the atomic level. It's not exactly a happy thought, is it? Aside from the destruction, though, black holes are also widely known for distorting the time and space around them. In reality, if we ever shared a planet with a regular, stellar black hole or bigger, we'd be dead far too quickly to notice any kind of strange time dilation or gravitational warping that might happen. Time dilation, in particular, is only really noticeable if you had an observer both inside and outside of the black hole. An impossible feat. Say a black hole really did appear here, pulled us all past its event horizon, and we were all alive and aware enough to know what was going on. All we'd really see is everyone else experiencing time and space, life and death in the exact same way as ourselves. To us, the time warp wouldn't exist. But what about for an extremely tiny black hole? Does such a thing even occur? So-called micro black holes are still hypothetical, but this doesn't mean they're not real. For years, now, people have worried that particle accelerators, specifically the Large Hadron Collider in Europe, might be able to create black holes. And, of course, if they ever did, then this really would constitute a black hole appearing on Earth. Experiments started at the LHC in 2010, so they're more an ongoing study nowadays, a background story for life on Earth rather than regular, headline-making news. Still, if anything ever did go wrong, we'd all know about it. It's thought that, were a micro black hole to appear on this planet, whether as a result of particle accelerator experiments or not, then it would instantly dissipate because of its small size. Which sounds like a good, non-life-threatening situation, but, unfortunately, it's also believed that the energy released just from that happening would easily dwarf that released from a nuclear bomb. While this wouldn't necessarily be world-destroying, it would certainly kill everybody in the immediate area, potentially millions of people. If we had a particle accelerator at the bottom of the sea, rather than beneath the France/Switzerland border as per the LHC, maybe micro black hole creation wouldn't be quite as deadly to humans, though it would still devastate marine life and trigger untold tsunamis. A slightly larger black hole, but one that's still smaller than a stellar black hole, would bring its own set of problems, too. Say one with close to the mass of Earth opened up tomorrow, a wholly hypothetical prospect, because science doesn't yet know of a way that a black hole like this could even happen. Well, it would also wreak havoc. A black hole of this size would still look very small to the human eye, but it would be strong enough to slowly consume our entire planet piece by piece. We might be afforded a little bit of time enough, perhaps, to escape to the Moon or Mars in a far future world, but before long, with the planet itself devoured, such a black hole could even take Earth's place in the solar system. The Moon would now orbit around it, potentially without any other major changes. Theoretically, though, the opposite could also be possible. You can fit all of the other solar system planets end to end between the Earth and the Moon, so our closest satellite is still a long way away. If a black hole, then, with the same mass as the Moon, took up the same spot as the Moon, could it also orbit around us? For at least a short time, maybe it could, even if it would appear tiny compared to the Moon, and far too tiny to see from the ground. Thanks to modern science and astronomy, we know today that many exoplanets and stars orbit black holes perfectly safely out in the universe. We also know that black holes can orbit each other, and that our galaxy has a supermassive black hole at its center, or, according to some theories, two supermassive black holes at its center. What's especially crucial to this thought experiment, though, is that scientists have also discovered before that a black hole can orbit a star. The star just has to be more massive. Ultimately, black holes are objects in space like everything else, and they behave according to the mass of what's around them. Place a hypothetically moon-sized black hole precisely where the Moon is now, then, and the night sky would look totally different. And scientists would have the ultimate opportunity to study these cosmic enigmas at close quarters. Today, we have just a single, blurry image of an extremely distant black hole, but now, we'd have the universe's ultimate destroyers within touching distance. The downside? Well, having a black hole that close to us could well prove unsettling. Every time we looked into the sky, there'd be a reminder of how close we are to a quick demise via the dreaded spaghettification. But it's perhaps worth noting that Earth is already affected by distant and dangerous celestial objects, not least the Sun. While sunlight is needed for life on Earth, the Sun would be just as dangerous as a black hole if it were ever to move closer to us. In terms of potential for danger, falling into a star isn't any more or less fatal than falling into a black hole. Both will quickly kill you. Yet, we're obviously used to the Sun. It's been there for all of our lifetimes, and throughout Earth's existence, so we rarely imagine that it will be the end of us. Perhaps, in an alternate world where a tiny black hole hung in the sky as well, we'd grow to feel the same way about it. On the planet's surface, even a micro black hole could have devastating consequences, potentially killing millions or even the Earth's entire population. If the right-sized black hole appeared just in the vicinity of Earth, though, we might, maybe, stand a chance. And that's what would happen if a black hole appeared on Earth. What do you think? Is there anything we missed? Let us know in the comments. Check out these other clips from Everything But What, and make sure you subscribe and ring the bell for our latest content.